Problem I've selected is 9x plus 2 divided by 3x squared minus 2x minus 8 plus 7 over 3x squared plus x minus 4. So here's the rational expression that I've chosen. Mind you, can't use this on a calculator, so you got to know the idea and the concept of having common denominators. So all you're doing is multiplying a bunch of things together to make the denominators the same. And whatever you multiply the denominators by, you must multiply the numerators by to keep it as a multiplication of 1. So here we go. This value right here, 3x squared minus 2x minus 8. I'm adding fractions. I haven't even begun to look at the numerator. Forget about it. I'm not going to look at it until I need to look at it. So up here, I'm going to look at the bottom. This is 3x squared minus 2x minus 8. Well, how am I supposed to know what multiples of this is going to multiply by that will make something like this? Well, the easiest way to do this is that you have to look at what are all the factors that go into this. So the nice thing about quadratics, again, is the fact that they have very specific factors. So I begin to factor this, and a quadratic always factors into a linear times a linear. So here I go. This quadratic, and I shouldn't say always does, but most of the time will. So this part here, because sometimes things just aren't factorable. This part here is 3x plus 4 times the quantity of x minus 2. And the way I got that is I looked at the factors of my very first coefficient and the factors of my last term, which is the positive 8, and I said, which ones of those can I play with? So what I want you to note is that the coefficient of x is both factors of 3, and the 4 and the 2 are factors of 8. So how can I manipulate those to when I multiply my things through, I get a negative 2x, and that's what I'm looking at. So I now get 3x plus 4 times the quantity of x minus 2. I then come over here, and I look at this one, and lo and behold, I'm going to get 3x plus 4, and then x minus 3. So that's what that factors into. So I'm going to rewrite this expression now as being this. So for me, I'm just going to erase. If you need to go back and see what it is that I've got, you can go ahead, but here's the original, and now I'm erasing it. So you can just follow along. You can write it on your next line if you want, but don't write it like this. So here we go. I'm just rewriting it. So my next line, if I were doing this on paper, would look like this. And okay, so now that I've written the denominator, as its factors, I'm going to look at the numerators. And at this point, I'm going to check, okay, can I rewrite these also as being factors? Because now that I've started factoring, I'm going to start the ball rolling and look at the numerators. Can I factor the numerators? 9x plus 2, can it be factored? Well, it's a linear, so the only option I have here is GCF. There is no value that 9 can be divided by, that 2 can be divided by, so no. And then I just have 7, a constant. Constants can't be factored. So I now move on, and I've got this. So what I now need to do is I need to look at the denominators and say, okay, what multiples does one denominator have that the other one also has? And if I take a look at this, this one has a 3x plus 4, and this one has a 3x plus 4. So that's cool. Both of these things have multiples of 3x plus 4. But what does the one have a multiple of that the other doesn't? Because if I take those two amounts and multiply them together, well then guess what? They both then have those multiples. So that's what I'm going to take a look at over here. So this one has a multiple of x minus 3. This has a multiple of x minus 2. Well, if I multiply those together and stick them in both denominators, then guess what? They all have them. So this comes back to that idea of I must multiply by 1. So this one over here does not have the multiple of x minus 3. So I'm going to go ahead and multiply the bottom by x minus 3. Now remember, what you do to 1, you must do to the numerator. So if you do x minus 3 to the bottom, you must multiply x minus 3 by the top. So it's the quantity of x minus 3. So now I begin to multiply these things. And again, keeping in line with the idea that I'm really just multiplying by 1. I then come over here. Since I multiplied this by 1, I must multiply this by 1. But remember, my 1's don't have to look exactly the same. So this one doesn't have an x minus 2. So I'm going to multiply the bottom by x minus 2, so therefore I multiply the top by x minus 2. And again, I'm just multiplying by 1. So I haven't changed the amount of anything. This function is still 9x plus 2 divided by 3x plus 4, x minus 2, plus 7 divided by 3x plus 4 times the quantity of x minus 3. I'm now just multiplying by 1, and it's going to change the look. And how does the look change? Well, here we go. The bottom, I'm just going to leave. The top, I am actually going to distribute this. So when I go ahead and I do my distributions, I'm going to get, so I'm going to redo this now. So x times 9x is 9x squared. X times 2 is a positive 2x. Negative 3 times 9 is a negative 27x. And negative 3 times 2 is a negative 6. So I've now got this expression of 9x squared plus 2x minus 27x minus 6. So I'm going to go ahead and rewrite this over here in the simplified form, which is 9x squared minus 25x minus 6. And the way I got that is I just combined my like terms. So that is still now going to be all over the quantity of 3x plus 4 times x minus 2 times x minus 3. Again, I'm not worried about the bottom quite yet. So I now have this bottom part. This is then going to be added to. Well, I do the same thing. I'm multiplying it by 7. So this quantity times 7 is just a distribution property again. So I now got 7x minus 14. So now that I have 7x minus 14, that is all over this same amount. So 3x plus 4, x minus 2, and x minus 3. So now I just have these expressions. So now that my denominators are the same, now what I can do is I can go ahead and combine like terms in my numerators. So I'm going to go ahead and do that. I'm going to erase the step above here so I have space to do it. So here we go. Now, because I'm combining the numerators, that means I can write this all under one denominator. And the one denominator here is 3x plus 4 times the quantity of x minus 2 times the quantity of x minus 3. So now that it's all over that, I'm going to go ahead and combine. 9x squared plus, there is no other x squareds over here. Okay, so it's just going to be a 9x squared. I then have a negative 25x with a plus positive 7x. So negative 25 plus the positive 7 is going to give me a negative 18x. I then continue on. Negative 6x plus negative 14 is a negative 20. So now I have negative 20. So now what I'm going to do is, now that I've created this new expression from this part right here, which I'm going to erase in about a second because there's more I can do. Because remember, you must leave everything in simplest form. So what I need to check for is, does this reduce? And what I mean by reduce, it's kind of like the same topic as if you had something like 8 over 10. So what factors of 8 go into the and are similar with the factors of 10? Well, 8 is the same thing as 2 times 4, and 10 is the same thing as 2 times 5. So 2 over 2 is 1, so therefore 8 over 10 reduces to 4 over 5. Well, guess what? I've now created this new expression. So what multiples of this do I share in common with the multiples of this down here? This one's already written out as all of its multiples, but this one is not. So I have to go through and I'm going to factor this. So the way that I factor this is, I'm going to take a look now at this and I'm going to say, okay, the factors of 9 and the factors of negative 20. What are they that I could make a value of having negative 18x? So now when I go through, okay, so let me erase this. I'm just going to check, does it work? So the factors of 9, there are only 2. So here we go, 9 and x. And then I've got an x. So those are the coefficients for the 9. So I have to figure out, is it possible to make a negative 18? So what I have here is I've got maybe 10 and 2. So I'm going to look at the factors of 20. And the factors of 20 are 1 and 20, 2 and 10, 4 and 5. And then I'm done. So what I'm going to check now is, do any of these, okay, can I take any factors of 9, which are 1 and 9, and 3 and 3? So I'm not automatically going to put a 9 there. Sorry that I did. I'm going to check, can I make negative 18? So here I go. So if I take a look at this, since that's a negative, I know right now that I'm going to have to plus and I'm going to have to minus something. So here we go. If I take a look over here, I'm going to check if any of these might possibly work. 2, okay, I got a 2 over here. So that's with the 20, so could it possibly be a 2 and a 10? I don't know. Let's check it out. So I have 3 times 2, which is 6, and 3 times 10, which is 30. 6 and 30, not going to work. So it doesn't matter if I added or subtracted, I'm not going to make 18. So now I'm going to check, okay, the 2 didn't work. So does the 2 maybe work with something else? Well, 9 times 2 is 18, and 1 times 10 is 10. So 18 and 10 is not going to make 18 anyhow. So now I'm going to continue going on with this. So now I'm going to check, okay, well, let's see, I got a 3 here, and I got a 4 over here. So let's check, maybe that'll work. So 3 times 4 is 12, and 3 times 5 is 15. Okay, that's not going to work for me to make negative 18. So I'm going to continue on with this. So I'm going to check. I've got there and there. I've checked that. This 3 is going to be 3 and 60. Not going to happen. So can I make negative 18 in the first place? Or is this just it? So then I'm going to check one last time with 1 and 9. So 1 and 9, I'm going to check 4 and 5. So 9 times 4. 9 times 4 is 36. 1 times 5 is 5. So that doesn't work either. So lo and behold, my final answer is just simply left as 9x squared minus 18x minus 20. And please note how you have to go through that process that I just walked through. I didn't want you just to stop there and say, oh, I'm done. Because you're not. You have to check, is there factors of this that go into that? Okay, so that's your final answer.